So now we're up to speed on providers. We know how to create providers. We know how to create providers for resources of various types. And we also know how to register providers. And providers are an important part of dependency injection. Now we're going to learn about yet another very important part of dependency injection, and that's injectors. Injectors really do the heavy lifting of dependency injection because they're responsible for actually creating the instances of resources, and they create those instances as per the instructions of the providers. Injectors also oversee when, where, and how many instances of a resource that should be created. An injector is also responsible for injecting the correct instance of a resource into a consumer. There are two types of injector. There are environment injectors and element injectors. Every Angular application that you create has at the very minimum 3 injectors. And those 3 injectors are the root injector, the platform injector, and the null injector. Every Angular application has these 3 environment injectors. As you add features to your Angular application, injectors get created for each of those features. For example, in a module-based application, when you add lazy loaded modules to your application, an injector gets created for each one of those lazy loaded modules. In a standalone based application, when you add routes to your application, injectors get created for each one of those routes. When you add components and directives to your application, element injectors get created for each of those components and directives. The element injectors that are created mimic the DOM tree. All of the injectors within an Angular application are in a hierarchy, with the element injectors being at the lower level of the hierarchy and the environment injectors at the top of the hierarchy. Depending upon the location of a consumer, when a consumer requests a resource, by having that resource in its constructor, the entire hierarchy of injectors will be traversed until the registered resource is found. And if no registered resource is found, then the null injector is reached, and that's when we see that no provider for error in our console. The way in which injectors and providers work together is as follows. When a service registers itself using the provided in root metadata property, the root injector creates an instance of that service, and any consumer that requests that service in its constructor will first look to itself for a registration of that service. And if it's not found, it will then look to its parent. And if the service is not registered with its parent, it will look up to either the module injectors for a module-based application or the root injectors for a standalone application. And if a registration for the service is not found at either of those levels, then it will move on to the root injector, where it finds an instance of the service because the service has been registered at the root level. Then the root injector will inject that instance of the service into the consumer. And this is the same procedure if a service is registered using the provided in platform property. Then the platform injector will create an instance of the service. And thus far, we've only seen registration at the root level of our demo application. We've seen that with the provided in root, and we've also seen it in the application config providers array. When we register a provider by adding it to the providers array of the application config, the root injector again creates an instance of the service at the root level. So now let's take a look at what occurs when we register providers in a component. Back in our demo application, both of our components are using the display service, and as you remember, the display service is getting its source data from the HTTP client, and this is the source that's being displayed by both of our components. Now let's modify the code so that the display component replaces the use of the display service with the simple service. And remember, the simple service needs a source info string in its constructor method. But instead of registering this provider for the display component in our application config, let's register it here in the display component itself. So to do that, we add a providers array, and we add a provider to this providers array where provide is the display service. And to have the simple service replace the display service, let's use factory, and we'll create a new instance of simple service, and we'll pass it for the source info string. Let's pass it simple service from display component. And so let's make this a function. Notice that not only is the display component using that new provider, but also the nested other display component, its child display component, is also using that new provider. The sibling other display component is still using the display service. So how is this happening? Well, the display component traverses the injector hierarchy, and it finds a provider for display service in its own component. Therefore, it uses the provider that is registered in its component. It goes no further up the hierarchy. And the same goes for the nested other display component. It looks to itself for a display service, but there is no provider for the display service in its providers array. So it traverses the hierarchy and it finds in its parent, the display component, a provider for the display service. So it uses that instance of the display service. The other display component that's a sibling to the display component, on the other hand, it's at the level of the app component, which is here. And of course, the app component does not have a providers array. It doesn't have a provider for the display service. So this component moves up the hierarchy to find a display service in the root injector. And it finds it because display service has a provided in root property, and therefore the sibling of the display component gets its instance of the display service from the root injector. Now, what if we were to register a display service here in the other display component? Let's do that. Let's add a providers array, and let's provide for display service. Let's use another use factory, and use a different instance of simple service where we pass simple service from other display component. And now we see that both the nested child other display component and the sibling other display component, they both use the display service registered in the other display component. The nested other display component doesn't have to move up the hierarchy to find an instance of the display service because there's one registered in its own component. So both the nested and the sibling other display components use the display service that's registered in the other display component. Now, because both the display component and the sibling other display component are children of the app component, let's see what happens if we add a provider for display service in the app component. And I'll just copy the provider code from other display service, and I'll add the provider to the app component. And let's just change the source so that it says from app component. Let's add the import for simple service. And let's see what we get. Are you surprised that nothing has changed? Well, that's because each of the components, each of the child components of app component, that's the display component and its sibling other display component, they both have their own provider for display service in their component providers. Other display component has its own display service, and display component has its own display service. So they don't have to traverse the hierarchy to get to their parent app component for a provider of display service. They have their own. So that's the way that the registration of providers works with the injectors. A consumer looks first to its own array of providers for its resources, and if it doesn't find it, it traverses the hierarchy of injectors. First, it moves on to its parent, and once all of the element injectors are exhausted, that is, there's no provider found amongst the element injectors, it moves on to the environment injectors. First with either the module injectors or the root injectors, depending upon the type of application. And then if no provider is found there, it moves on to the root injector. And again, if no provider is found in the root injector, it moves on to the platform injector. And if no provider is found there, it moves on to the null injector. And let's have one of our components traverse the hierarchy and make it to the null injector. Let's remove the provided in root property from display service. Let's comment that out, and let's comment out the provider for the other display component. And notice what happens. The sibling other display component is now using the display service, the replace display service from the app component. Let's also remove this provider in the app component. And what do you think we should get? Well, we should get an error, right? Because the sibling other display component should reach the null injector. So let's comment out the provider in the app component. And notice our app is broken, and that's because, of course, if we go to the component, we get a no provider for display service. And that no provider for display service is coming from the other display component that's at the app component that is the child of the app component. So now you see how the hierarchy of injectors works and how it works to fulfill the request for resources for all of the consumers, and how each consumer traverses these injectors to ultimately get to an injector that can provide its requested resource. And if it traverses all the way up the hierarchy and reaches the null injector, well, then we get this no provider error.